Hey, thanks for coming back. We are now at U 4.11, the sine law. We are messing around with obtuse angles. Okay, so this is, oops, I'm going to go 90 degrees to 180 degrees. Okay, and we just did some calculations in the previous video where I had the angle and it was obtuse and everything was fine. This is where we have to watch. It's when we're actually calculating the angle. So whether a triangle is acute or obtuse makes no difference in the sine law unless you're solving for the angle, which is what I just said. But I thought I'd read what I wrote. Then it doesn't matter till the very last step where you check to see if it's reasonable. So that checking that I've been doing all the way along now becomes very important. I'm sorry, me and the mouse. There it goes. Okay, so this must be angle X. Make this little x, and we'll call this A and little a. So let's just do the magic. There's my beautiful matchy-matchy pair. You're going to be so sick of it, but we're going to flip to the cosine law in a little bit. No more matchy-matchy. All right, so we got A over sine A is equal to X over sine X. Throw in my numbers, 25 sine 33 is equal to 43 sine X. Okay, cross multiply, 25 sine X is equal to 43 sine 33. You guys should be so good at this by now. Divide by 25. Oh, I just had a moment. In case you're struggling, I think you can set the video to like half speed too. So maybe then you could write and keep up with me because I know I do these fast, especially on days where Timmy is involved. All right. Oh, there's my calculator. Okay, where am I going to move? Dumb light. There. 43 sine 33 divided by 25. All right. So oh, maybe I moved that too fast. There. I'll get it. 0.9367. Nope. Okay. I'll do it right. Rounding. It doesn't matter because I just used the value of my calculator. So now remember to get the actual angle X, not the sine of the angle X, because the sine is that ratio thing. We do second sine equals, and it gives me 69.5. So I'm just going to put 70 degrees. Now, the question is, could this be 70 degrees? Well, maybe, but I'm going to be honest with you. Most of the time when I get these diagrams, wherever I get them from the internet, they're probably to scale. And this actually also says we're dealing with obtuse angles. So probably not 70. So let's figure it out. So all you do is 180 minus 70. Look at that, witchcraft. Did it without a calculator. So angle X is equal to 110 degrees. Now, how come I did that? I said, because clearly in my diagram, this is the longest side, right? You don't need to put this on yours, but just to kind of explain. If this is 33 and this is 70, let's pretend we didn't know this, and then I'd have 180 minus 33 minus 70. And that would make this angle over here 77 degrees. And that can't be because this line here is the biggest one. Okay? So just be careful when your diagram looks like it's over 90. Do the quick check. You'll probably be fine. That being said, I'm going to let you in on a little secret. On this question, maybe 6 marks. 5 of them are getting this far. The last mark is realizing it's an obtuse angle. So even if it's really confusing, at least do this part and get most of the marks. Then you come back, you do your math corrections, you get the half of the leftovers. We're golden. You're golden. Right. Oh, no. No, no, no. No diagram. Okay. In an obtuse triangle. Okay. At that point, I'm just going to draw. Oh, my brain always wants to make 90-degree triangles. There. So there's my obtuse angle. It says angle B is 23. So I'm going to put B here. 23 degrees. And over here is 40 centimeters. Okay. Side A is the longest. So that means this is little a. This is big A. Longest side of the triangle thinks of 65 degrees. Determine the measure of angle A to the nearest tenth of a degree. Okay. We got our matchy-matchy set. So actually we're golden. So turn off the video, do the question, or pause the video, do the question, and then come back and see how I did. You might catch me in a mistake. These are not guaranteed to be 100% perfect. All right, so B over sine B is equal to A over sine A. 40 over sine 23 degrees is equal to A. Oopsie. Holy. I hope you guys are all yelling at me. It's not degrees. That's centimeters. My bad. 65 over sine A. Cross multiply. 40 sine A. 65 sine 23 degrees. Divided by 40. Divided by 40. I'm sorry, I left you such a poopy little space to do this. And let me just move my screen, my camera. There we go. There. Get everything back. Now we lost. This disappears. So sine A is equal to 65 sine 23 divided by 40. Get 0.6349. Come on. Okay. So on my calculator, it's always second in sine. Yours might be shift. It just depends on which calculator you have. So angle A, remember when you do that shift sign, you go from the word sign to an angle. And 39.41, angle A, 39.4 degrees. Now, I did 0.4 because the question said nearest tenth of a degree. But there's no way that is the biggest angle of a triangle because you've got 180 altogether. Subtract the 23 we already have. Now subtract 39.4 that we just calculated. That would leave the remaining angle to be 117. And the question says, well, the question says the side A is the longest. So that means angle A has to be the biggest. So this is going to be one of those times where you just go 180 degrees minus 39.4 degrees. 180 minus 39.4. So angle A is equal to 140.6 degrees. Again, that's a little tricky, but just watch at the very end of the questions. Make sure you're checking. So that means 140.6 over here. That makes sense, right? That's my longest side. All right. Thanks for joining me for another one of these fun math videos. You are going to be done Math 20 in no time.